Chapter 2. Science and the Nature of Reality. When we ask, what is reality? We step into a question that has captivated and confounded humanity for millennia. For most of us, reality is what we can see, hear, touch, taste, and smell, the physical world around us, seemingly fixed and undeniable. But when we look closer, through the lens of science and the introspection of philosophy, we begin to see that reality is not as simple or solid as it seems. Instead, it appears to be a dynamic interplay of perception and energy, shaped by the awareness of those who observe it. Before we go further, a brief note on perspective. Physicists have proposed many interpretations of quantum phenomena, some mechanical, some mental, and the debate remains unresolved. Here, we approach reality through the lens that consciousness itself plays an active role in shaping what we perceive as the physical world. Not as a belief to defend, but as a hypothesis to explore. As the chapters unfold, the aim is to show that this isn't just a poetic possibility, but an emerging inevitability, one that both science and experience are steadily pointing toward. If you hold a different interpretation, I invite you to simply stay open. Read on as an experiment in perspective, and see where the evidence leads. Throughout history, science has served as our lens into the unknown, a disciplined quest to uncover the laws of the universe. It has illuminated the vastness of space, the complexity of biology, and the mystery of the human mind. But in recent decades, science has begun to uncover something even more profound. It has turned its attention to the fundamental fabric of existence. Consider this. What if everything you thought was solid wasn't actually solid at all? What if time didn't move the way it feels? What if existence itself wasn't fixed and objective, but flexible, fluid, shaped by observation and awareness? As incredible as it may sound, this is precisely what many of today's most groundbreaking scientific discoveries are beginning to reveal. In doing so, they seem to be reaffirming what many ancient mystics, sages, and spiritual teachers have suggested for millennia: that the world we experience is not ultimate reality, but a dynamic field of energy and possibility. The study of subatomic phenomena, one of the most revolutionary fields in modern science, has upended the classical view of a concrete, predictable universe. It shows us particles that exist in multiple states at once, entangled particles that communicate instantaneously across space, and outcomes that change depending on whether or not something is watching. And it doesn't stop there. Einstein's theory of relativity shattered our understanding of time and space, revealing that they're not absolute frameworks, but dynamic, interconnected aspects of a deeper field. The flow of time is not a universal constant. It is relative, dependent on motion, gravity, and perspective. In other words, time itself bends with context. Space stretches. Reality warps. This suggests that our experience of time and space is not a passive backdrop, but a flexible, responsive field that behaves differently, depending on how it is engaged with. Together, quantum mechanics and relativity point to a truth more mysterious than most are willing to accept: that the world we take for granted, the seemingly fixed world of objects, clocks, and linear time, may be an interpretation shaped by perception, not a fundamental truth. This chapter will explore the scientific discoveries that are dismantling our old assumptions about space, time, and matter. We'll examine how leading-edge physics suggests the world we see is not quite as it seems. And we'll consider the deeper possibility that consciousness itself is not something contained within reality, but something that shapes it. One of the most startling revelations of modern physics is that what we perceive as firm, tangible objects are, at their core, composed almost entirely of empty space, structured by invisible forces. Imagine an atom. You might picture a miniature solar system, with electrons orbiting a nucleus like planets circling the sun. While this image is helpful as a visual aid, it misses the deeper reality. If an atom were expanded to the size of a football stadium, the nucleus would be no larger than a marble or a pea in the center. The electrons would be like grains of dust, whirling somewhere near the outer bleachers. Everything else in that massive structure, empty space. And yet, it is from trillions of these mostly empty atoms that everything in our world appears to be made. Technically, that space is not empty. It is filled with fields and forces, but for general purposes, it behaves like emptiness. Now consider this. When we gaze into the night sky, we understand instinctively that space is almost entirely emptiness. We accept the immense gaps between stars and galaxies, the unfathomable void between planets. But when we turn inward, toward the atomic and subatomic, we resist applying that same understanding. Why is it easier to accept vast emptiness in the sky than it is within our own hands? Why do we so readily accept the vast space between stars, yet resist the truth that our own bodies are built on that same spaciousness? Even though, at the foundational level, your body mirrors the structure of the cosmos, almost entirely space, most people would laugh if told their body wasn't really there, in the solid way they perceive it. But that's exactly what the science suggests. This invites a deeper question. What makes one scale of reality more real than another? Why do we trust our senses at one level while dismissing the truth at another? Perhaps our definition of solidity has less to do with objective truth, and more to do with perspective, scale, and belief. Building on the idea of empty space, consider something as simple as placing your hand on a table. It feels undeniably solid, as if your hand is making direct contact with a surface. But at the atomic level, that contact never truly happens. The atoms in your hand and the atoms in the table are separated by vast empty space, and they never truly touch. What you're feeling isn't physical contact, it's resistance. Electrons, which carry negative charges, repel each other when brought too close together. This electromagnetic repulsion is what gives rise to the sensation of touch. Like two magnets that refuse to meet, your atoms are simply interacting through force fields. But if everything is mostly empty space, air, water, and even the table in front of you, then here's a question worth asking. Why can your hand move easily through air or glide through water, but stops at the surface of a table? If they're all made of atoms, and atoms are mostly empty, why does one feel soft, another fluid, and another hard? Scientists who take the materialist view would argue that it's because of how the atoms are arranged and how their fields repel one another. But empty space is still empty space. Electromagnetic phenomena are just forces. In the same way that there's nothing solid between two magnets repelling each other, there's nothing solid between two atoms repelling each other. And if there's nothing there, then there's nothing there. It wouldn't be the first time a dominant viewpoint within physics later proved incomplete. For centuries, scientists believed in the ether, a mysterious substance said to fill all space and carry light waves, much like air carries sound. It was accepted by nearly every physicist until the Michelson-Morley experiment famously disproved it. Today we know light doesn't need a medium to travel through. The ether was a well-constructed theory, until it wasn't. If even the concept of solidity dissolves under closer inspection, what else might we be misunderstanding? Perhaps the issue isn't just what we're seeing, but how we're seeing it. For centuries, physics has revised its assumptions as deeper layers of reality come into view, from the ether to relativity to quantum theory. Now the question grows even stranger. If modern science shows that observation plays a critical role in shaping what is seen, yet the tools of observation are themselves made of empty space, then what, or who, is truly observing? What if scientists aren't simply recording outcomes, but participating in their creation? In a universe where everything, including our instruments and our own bodies, is composed of the same fundamental emptiness, perhaps measurement doesn't just reveal reality. Perhaps it helps define it. The evidence would still appear to line up, but only within the boundaries of that belief, just as the ether once did. At first glance, this might sound far-fetched, but keep it in mind as you read on. Ask yourself later if it still feels so unbelievable. Many ideas we now accept as truth were once dismissed as impossible. In that same spirit, what we currently believe about matter and solidity may one day be replaced by something even more astonishing, something that reframes our most basic assumptions about the physical world. And if that sounds far-fetched, consider just how much emptiness we're talking about. If you removed all the empty space from the atoms in every single one of the 8 billion human bodies on Earth, compressing only the so-called solid matter, the entire population would fit into something the size of a sugar cube. That's how insubstantial physical reality truly is. Let that sink in. Here's something to reflect on. If everything we call solid is mostly space and energy, then what does it mean to have a body, or anything at all? Do our bodies, and the world around us, truly exist as fixed objects? Or are they shifting patterns of energy and structure, briefly taking form in a vast field of possibility? This isn't a new idea. It's a question that has reverberated through the minds of some of the most brilliant and influential thinkers in human history. Philosophers, scientists, and sages alike, each wondering if what we perceive as solid and real might be something far more malleable and far more mysterious. Quantum mechanics introduces phenomena so strange, they seem to defy not only common sense, but the very notion of an independent, objective reality. At the smallest scales of existence, particles don't behave like tiny billiard balls following predictable paths. They behave like probability waves, potential outcomes waiting to be resolved. Two of the most bizarre yet experimentally confirmed features of quantum physics are superposition and entanglement, phenomena that suggest the universe is not built from isolated parts, but from relationships, potentials, and dynamic interaction. In the quantum world, many of the most brilliant minds believe that particles such as electrons or photons do not exist in one fixed state until they are observed. Instead, they exist in what's known as superposition, a blending of all possible states simultaneously. It's not that the particle is undecided, it literally exists in multiple forms at once. Imagine flipping a coin and freezing time mid-air. In classical reality, you'd say it's either heads or tails, you just don't know which yet. But in this view of quantum reality, the coin is actually both heads and tails simultaneously, until something observes it. The moment of observation collapses the superposition into a single, definite outcome. Even more mysterious is quantum entanglement, a phenomenon where two or more particles become so deeply linked that the state of one instantly determines the state of the other, regardless of the distance between them. Change one, and the other responds immediately, even if it's on the other side of the galaxy. Einstein famously called this spooky action at a distance, because it appears to violate the universal speed limit, the speed of light. Yet entanglement has been repeatedly confirmed, most famously in the 1982 aspect experiment, and more recently through quantum teleportation and Bell test violations that leave no room for classical explanations. This suggests that the universe is fundamentally non-local, not composed of isolated parts, but woven together by an invisible thread of unity. These phenomena are not speculative theories, they are repeatable, measurable facts. And yet, they defy every intuition we have about space, time, and identity. Superposition tells us that reality waits for interaction. Entanglement tells us that nothing is truly alone. Together they challenge our understanding of what is real before it is observed, and what it means to be connected across space and time. They leave us with profound questions. What is the nature of existence before it's seen? Is reality waiting for us to define it? And if distant particles remain forever linked, what else might be connected that we haven't yet detected? One of the more profound discoveries in quantum mechanics is the observer effect, the idea that the act of observation changes the outcome of a quantum system. It's a repeatedly verified phenomenon that challenges the very notion of an objective universe existing independently of awareness. At the heart of this mystery lies a mind-bending theory. On the quantum level, reality doesn't settle into a definite state until something interacts with it. This turns the old notion of an objective, pre-existing world on its head, hinting instead at a realm of probabilities that only solidify through interaction and awareness. It's a concept that resonates not only in laboratories, but also in philosophy and ancient spiritual teachings. The first law of Hermeticism, for example, declares, "All is mind, the universe is mental." In Hinduism, the Mandukya Upanishad describes the world as a projection of consciousness. In Buddhism, the concept of dependent origination teaches that reality arises through perception and interrelation. And across the Abrahamic religions, the power of belief is central. Faith is often portrayed not just as trust in the divine, but as a creative force that shapes outcomes. "According to your faith be it unto you," says Jesus in the Gospel of Matthew. Could it be that science is beginning to circle back to a truth mystics and sages have pointed to all along? The most famous illustration of the observer effect is the double-slit experiment. In this setup, individual particles, such as electrons or photons, are fired toward a barrier with two slits. Behind the slits is a detector screen to capture where the particles land. Here's where it gets strange. When unobserved, these particles don't act like solid objects. They behave like waves of possibility. Over time, even when fired one at a time, they build up an interference pattern on the detector, a pattern that suggests the particle went through both slits at once and interfered with itself. But according to the math, and especially Richard Feynman's path integral formulation of quantum mechanics, this goes even further. The math doesn't just say the particle goes through both slits. It says the particle takes every possible path from the emitter to the detector simultaneously. This includes the path through the left slit, the path through the right slit, both slits at once, neither slit, and a looping path that goes forward, back, around, and even bounces off itself. Each of these paths is assigned a probability amplitude, a complex number whose interference with all the others determines the final outcome on the detector screen. Only when we measure the particle, by placing detectors at the slits, does this infinite sea of possibilities collapse into a definite path. The interference disappears and the particle chooses one slit and one path, possibly because now it's being forced to commit to a reality. The interference pattern has been observed with electrons, atoms, and even molecules. The larger the particle, the harder it is to preserve its wave-like state, but the principle remains. Observation transforms potential into experience. So what are we looking at here? A particle that doesn't exist in one place, or take one path until we force it to. A reality where every potential outcome is present until observed. And a universe that doesn't simply unfold mechanically, but one that waits for an observer to look before deciding what to become. Reality, in this view, doesn't simply happen on its own. It waits for something to look before becoming one thing or another. In other words, there is no separation between the observer and the observed. What we call reality may not simply be watched by us. It may be shaped by our attention. This reframes a fundamental question. What if we are not mere spectators in the universe, but participants in its unfolding? If you ask the old question, if a tree falls in the forest and no one is around to hear it, does it still make a sound? This perspective would go even further. Without the observer, There's no sound, no fall, and perhaps not even a tree. This concept is famously illustrated by Erwin Schrödinger's thought experiment, involving a cat, a flask of poison, and a radioactive atom placed inside a sealed box. According to quantum mechanics, the atom exists in a state of superposition, both decayed and not decayed, until it is observed. If the atom decays, it triggers a mechanism that shatters the flask, releasing the poison and killing the cat. The bizarre implication, according to the laws of quantum mechanics, is that until the box is opened and observed, the cat is simultaneously both alive and dead, a state of superposition. Only the act of opening the box and observing the cat forces it into one definite state, either alive or dead. This thought experiment highlights the strange and counterintuitive role that observation seems to play in determining reality at the quantum scale. Schrödinger originally proposed this scenario not to support the Copenhagen interpretation, but to highlight its unsettling implications. He wanted to show how absurd it would be to apply quantum principles to something as large and familiar as a cat. And yet, the paradox holds. The mathematics remains sound, and experimental evidence continues to support the idea that observation is integral to how reality takes form. This leads to a deeply unsettling question. If a cat can be both alive and dead in a sealed box, then what else in our world might exist in multiple states, waiting for us to look? And if observation creates reality, then who or what is the ultimate observer? After Schrödinger's cat and the double-slit experiment forced us to question the role of observation in shaping reality, physicist John Bell pushed the mystery even further. In 1964, Bell proposed a theorem to test a fundamental question. Do particles have fixed properties independent of observation, or are those properties only determined when we look? Bell's theorem presented a brilliant way to test this by looking at pairs of entangled particles. If particles truly have pre-existing values, and if no information can travel faster than light, then certain mathematical relationships, called Bell inequalities, should always hold true. But they don't. In experiment after experiment, including the groundbreaking work of Alain Aspect in 1982, and even more sophisticated versions in recent years, Bell's inequalities have been violated. The data is clear. Either the universe is non-local, meaning particles can influence each other instantly across any distance, or reality itself doesn't exist until it is observed. Both options violate our classical intuition. And either way, the message is the same. Separation may be an illusion, and reality may not be independent of the observer. In daily life, time appears to move in one direction, a steady river flowing from past to present to future. Clocks tick forward, days turn to nights, and we age in a single, irreversible stream. Classical physics supported this view, treating time as a constant backdrop against which events unfold. But Albert Einstein changed everything. His theories of special and general relativity shattered the illusion of time as universal and absolute. They revealed time to be a flexible, dynamic dimension, inseparably woven with space. Together, they form the fabric of space-time, a unified field in which time can bend, stretch, and shift depending on speed, gravity, and perspective. This means that time does not pass at the same rate for everyone, everywhere. It's not a fixed metronome ticking identically across the cosmos. It's relative. For astronauts orbiting Earth, time ticks slightly slower than for people on the ground. In regions of intense gravity, time dilates. It literally moves more slowly. This isn't just theoretical. It's a measurable effect built into systems like GPS, which must continuously correct for time differences caused by speed and gravity. Without these adjustments, location data would drift by miles each day. What we experience as now may simply be our position along a curve in space-time, a personal slice of a much larger whole. Relativity redefined time itself, not as something fixed, but as something flexible and dependent on perspective. And the consequences can be profound. A spacecraft, traveling near the speed of light, might complete a round trip to a nearby star in just a few years for the astronauts on board. Meanwhile, decades or even centuries could pass on Earth. Events that appear to occur at the same moment for one observer may occur at entirely different times for another moving at a different speed. There is no universal now. The concept of simultaneity, once assumed to be absolute, breaks down at relativistic speeds. What we perceive as simultaneous is not a fixed truth, but a product of perspective, shaped by motion and position in spacetime. Just as space has height, width, and depth, time is a coordinate woven into the structure of reality. We don't simply move through space, we move through spacetime. These revelations overturn our everyday understanding. Time is not an external force ticking away independently. It is relative, observer-dependent, and inseparable from the conditions in which it's experienced. This opens the door to possibilities that stretch the imagination. While still speculative, theoretical models like wormholes and closed, time-like curves suggest that time travel may not be pure fiction, but a question of perspective, not propulsion. When the fabric of reality is shaped more by observation than by machinery, perhaps navigating time isn't about building something, but realizing something. The fact that such models are even mathematically permissible is astonishing in itself. But beyond equations and theories, the deeper message remains. Time is not fixed. It bends, flexes, and responds to perspective. And that realization changes everything. It suggests that our experience of time, like our experience of reality, may be more subjective than we've ever dared to believe. As if things weren't strange enough, physicist John Wheeler proposed a variation on the double-slit experiment that would challenge our understanding of causality itself. In the delayed choice experiment, the decision about how to measure a particle, whether to observe it as a wave or as a particle, is made after it has already passed through the slits, but before it hits the detector. Here's the kicker. The results show that the particle behaves according to how it is measured, even though the choice of measurement was made after it already decided its path. In other words, it's as if the particle waits to find out how it will be observed before finalizing what it did in the past. This isn't a fluke. Delayed choice experiments have been confirmed in increasingly refined forms, including quantum eraser experiments that show we can even erase the past, depending on what we choose to know or not know. These experiments suggest that the flow of time is not one way, that the past is not locked. That choice and observation in the present may shape what was. Taken together, Bell's theorem and the delayed choice experiment don't just disrupt our understanding of particles, they disrupt our understanding of reality itself. They invite a radical, humbling possibility that space, time, and matter are not fixed backdrops we live within, but fields of potential, collapsing into form through the presence of a participant. Building on these revolutionary scientific insights, many physicists have begun to entertain something truly paradigm-shifting. That what we perceive as fixed, objective reality may, in fact, be an illusion. And who can blame them? When you keep encountering the same results over and over, it's only natural to start questioning everything built upon them. When experiment after experiment shows that the material world isn't really material, when time itself turns out to be flexible depending on circumstances, time that's only measured by detecting changes in that same so-called material world, when both matter and time are shown to be influenced by the observer, something begins to shift in the psyche. The deeper we look, the more reality starts to slip through our fingers. We begin to see that the world may not be objective at all. It may be something far stranger. Here's how some of the world's most respected physicists have described these same conclusions. some directly, some with poetic astonishment, but all pointing toward a reality far stranger than we once believed. The world is not a collection of things. It is a collection of events. Time is not a backdrop. It is part of the dance. Carlo Rovelli. Time does not exist. Change exists. Time is only our way of measuring it. Julian Barber. Ultimately, all moments are really one, therefore now is an eternity. David Bohm. The distinction between past, present, and future is only a stubbornly persistent illusion. Albert Einstein. The distinction between reality and our knowledge of reality, between reality and information, cannot be made. Pascual Jordan. Observations not only disturb what has to be measured, they produce it. Anton Zeilinger, Nobel laureate. No phenomenon is a phenomenon until it is an observed phenomenon. John Archibald Wheeler. Everything we call real is made of things that cannot be regarded as real. Niels Bohr. I cannot define the real problem, therefore I suspect there's no real problem, but I'm not sure there's no real problem. Richard Feynman. The world is given to me only once, not one existing and one perceived. Subject and object are only one. Erwin Schrödinger. Remarkably, the revelations of modern physics are beginning to mirror insights that ancient spiritual teachers have voiced for millennia. That the physical world is not the ultimate reality, but a veil, a projection, or a dream-like construct. These traditions suggest that what we take as solid and linear is not the whole story, that behind appearances lies a deeper dimension of truth, one that cannot be grasped by the senses alone. Long before quantum theories or particle accelerators, mystics and sages across cultures spoke of this illusory nature of the material world. In Hinduism, it was called Maya, not simply illusion, but the powerful enchantment that makes the unreal appear real. Other traditions referred to it as the veil, the shadow world, or the waking dream. Now, as science reaches the edges of measurement and observation, it begins to speak in tones that sound increasingly similar, hinting that perhaps the ancients weren't speculating, but directly perceiving a truth modern instruments are only beginning to detect. Throughout history, spiritual texts and teachings have described this illusion, not with equations, but with parables, poetry, and metaphor. While the language differs, the message remains strikingly consistent, that what we call reality is not the full truth, but a limited lens through which we see the world. Here are just a few examples from across time and traditions that reflect this idea. Each one, in its own way, seems to point to the same profound insight, that the material world, and even time itself, is not the end of the story. It is the cover of a deeper book, beneath which lies a timeless truth. Christianity. What is seen is temporary, but what is unseen is eternal. 2 Corinthians 4:18. Before Abraham was, I am. John 8:58. There exists only the present instant, a now, which always and without end is itself new. Meister Eckhart. Buddhism. Form is emptiness. Emptiness is form. Heart Sutra. In the seen, there is only the seen. In the known, there is only the known. The Buddha. Hinduism. The world is Maya. Only Brahman, the eternal, unchanging source, is real. The soul is never born and never dies. It is unborn, eternal, ever existing. Bhagavad Gita. The Sufism, Islamic mysticism, describes enlightenment as stepping outside of time into the eternal now. Past and future veil God from our sight. Burn up both of them with fire. Rumi. Taoism. Reality is fluid, ever shifting. Rigid perception of form is illusion. Time is a created thing. To say I don't have time is like saying I don't want to. Lao Tzu. The 5 colors blind the eye, the 5 tones deafen the ear, the 5 flavors dull the taste, the chase and the hunt drive hearts mad. Things of the world gain by being seen as few. Tao Te Ching, Chapter 12. Zoroastrianism. Time was created by Ahura Mazda to bring order to the cosmos and allow humans to choose truth, Asha, over illusion, Droj. Sikhism. Who created time, and who knows its beginning? Guru Granth Sahib. The True One is pervading everywhere. He is not born, nor does he die. He does not come and go in reincarnation. Indigenous North American, Lakota. The longest journey you will make in your life is from your head to your heart. Often interpreted as a return to timeless, heart-centered awareness. Incan tradition, South America. Time and space are unified in the concept of pacha. Past, present, and future exist simultaneously and can be accessed through conscious awareness. Polynesian spirituality. Time is relational, not linear. Ancestors and spirit are present in the now. Mana, spiritual energy, transcends time. Building on the idea that science and spirituality seem to be in growing agreement, at least philosophically, that the things we perceive as real may not be truly real at all. Modern physics takes the conversation even further. It suggests that observation doesn't just influence reality, it may actually create it. And this isn't abstract mysticism or metaphor. It's what experimental data seems to increasingly reveal. This would mean that awareness, the simple act of noticing, doesn't just register reality, it participates in forming it. Consciousness wouldn't be passive, it would be something more than that. And perhaps most strikingly, this profound theory, that the observer shapes reality, echoes what mystics and spiritual teachers have expressed for thousands of years. Long before the language of wave functions and quantum fields, they told us that the world we see is not objective, but reflective. That what we experience out there is shaped by the state of our awareness in here. In their own words, they described reality as a projection of mind, a dream shaped by thought, a world colored by consciousness. Let's look at what some of these traditions have said, long before science began catching up. Buddhism. The mind is everything. What you think, you become. Buddhist traditions often describe reality as a reflection of mind. Hinduism. Separate things are only seen because of the mind that separates. Also teaches, you are what your deep driving desire is. Reinforcing that consciousness shapes reality. Hermeticism. All is mind. The universe is mental. Reality is seen as a projection of divine mind. Also, the sun is the mind of the all. Taoism. Reality is like water, fluid, shifting, responding to intention. Suggests that awareness and intention shape experience. Christianity. Do not conform to the pattern of this world, but be transformed by the renewing of your mind. Romans 12:2. A reminder that true change begins within. Reality shifts as consciousness does. If you have faith as small as a mustard seed, you can move mountains. Matthew 17:20. Belief is shown as a force that shapes outcomes. Faith appears approximately 336 times in the Bible, with only 2 mentions in the Old Testament, and the rest concentrated in the New Testament. Believe, and its variations, believed, believeth, believing, etc., occur around 322 times, demonstrating the Bible's persistent focus on the power of belief. The word belief itself is rarely used in the Bible, which seems to emphasize believing as an active process rather than a fixed concept. The Talmud. We do not see things as they are, we see them as we are, emphasizes the subjective, perception-based nature of reality. Sufism. The concept of transcending linear time through inner awareness implies that deeper reality is accessed through altered consciousness, not objective events. Taken together, these teachings suggest a deeper architecture beneath the surface of things. Whether through the language of sacred texts or symbolic parables, the message remains strikingly consistent. That reality is not something fixed and external, but something shaped, moment by consciousness itself. What we call the physical world may simply be the visible projection of invisible truths. And now, with science beginning to map what mystics long intuited, we find ourselves standing at a profound threshold, where ancient wisdom and modern discovery begin to speak with one voice. The discoveries we've explored, the emptiness of atoms, the relativity of time, the quantum strangeness of matter, and the baffling role of observation, are not confined to labs or equations. They have direct implications for how we experience life, how we see ourselves, and how we understand the world around us. They challenge the illusion of a solid, predictable reality, and reveal a universe that is fluid, relational, and deeply intertwined with consciousness. What's remarkable is how these revelations echo the voices of ancient wisdom, that we are not separate from the whole but participants in it, and how now science is beginning to say the same. Perhaps those spiritual masters, through meditation, introspection, or altered states, were tuning in to the same underlying structure of reality that physicists are now glimpsing through quantum equations and relativity. They didn't have particle colliders or atomic clocks, but they had inner access. And maybe that was enough. So what if the world isn't out there, waiting to be discovered? What if it's arising with us, because of us, moment by moment? The idea that we are active participants in the creation of the world around us is both humbling and empowering. It asks us to stop seeing ourselves as passive observers being carried along by forces beyond our control, and to begin recognizing our role in shaping what we experience. These revelations aren't conclusions. They're doorways, openings into deeper questions about what reality is and who we are within it. In the next chapter, we'll widen the lens to the universe's canvas and the outer fabric of existence. We'll look outward, from local experience to the cosmos, to explore how infinite realities may unfold at once, and consider the possibility that every potential world could exist within a broader field of possibility.